Hi, welcome to Database Management System. In this video, the following topics we are going to discussing. First one is conceptual and modeling using entities, relationships. Second one is using high-level conceptual data model for database design. Third topic is entity types, entity sets, attributes and key attributes. The total entire conceptual and modeling using entity relationships includes the following topics: using high-level conceptual data model for database design, entity types, entity sets, attributes and keys, relationship types, relationship sets, roles and structural constraints, weak entity, refining the entity relationship design, ER diagrams, naming conventions and design issues, relationship types of a degree higher than 2. Using high-level conceptual data model for database design. So in this high-level conceptual data modeling for data design, so we are going to see the steps how we are converting or else how we are designing a total database from how we are in the software engineering subject, how it includes the steps to design a project like requirement specification, analysis, design and coding. So the same steps we are following under the database designing also. By seeing this diagram will gives the clear picture about the different phases of the database designs. The entire design can be divided into two major sections. First one is designing of a database, which is considered as a backend component. Second, so designing of transaction processing, which is considered as a front-end component. You can see here this total part we can call it as a backend design. This total, so we can call it as front-end design specifications. So that is DBMS independent and DBMS specific manner. So we are defining or we are designing the database design. So basically, we will follow the steps from the requirement specifications. The first step in the designing the requirements collection and analysis. The database designers will interview prospective users of the application. This includes both active user and as well as passive users. The active users are users who actually use the application, and as well as the passive users are the users who have observed the system and have a knowledge about the application. And also the passive users may be the customer who use the database. These requirements are documented for the next stage. These requirements will help in designing the database. In parallel to the requirement, it is useful to specify the functional requirements, which include how user will interact with the system, and generally it includes both retrieval and as well as update functions. Once all the requirements have been collected from the users, these requirements must be analyzed to check whether all the requirements can be actually implemented or not. If it is implementable, then we will send it to the next step. The next step is conceptual design. Under this conceptual schema of the database, we are also calling it as conceptual design or relational data model. The user requirements are converted into entity types in this step, and relationships are formulated among the entities, and the constraints are defined for each individual entity types. This conceptual design is formulated using high-level data model. After the conceptual designing specifications, then the data will be forwarded for the further step, that is the logical designing specifications. So under this step, the database design is converted to a conceptual schema to the actual implementation of the database using commercial DBMS. For example, you can say SQL or Oracle. By using this commercial database or DBMS software, we are using to implementation. In this design, conceptual schema is converted from high-level representation, which is theoretical, to the logical representation, which is physical. This process of conversion is referred as a logical design or data model mapping. And in the last step, we can call it as a physical design. So the converted conceptual schema into a logical schema, the data will be stored into the database. That is, we are talking about the internal architecture of the data. The physical design phase is basically related to an internal storage structure of the database, where access path for saving the files and files organizations using indexes must be specified. In parallel with these activities, front-end application program are designed. You can see here, in parallel we are also designing application program in the front-end part. These programs are referred to as transaction implementation. Initial design process will involve identifying different functions that can be used by the users from the front end. These functions can be visualized as a form where the user will give inputs. So how the functions includes the insertion value or deletion or updation of values into the database. This requires the understanding of the logical schema and as well as mapping onto the transaction. This is about how this front end and back end will be designed for the database. The next point is entity types, entity sets, attributes and keys. Now in that we will discuss entities and attributes. Entity can be defined. It is an object with the physical existence, or it is a thing in the real world with an independent existence, or we can also call it as conceptual existence. We can call it as entities. Repeat, an entity may be an object with a physical existence, or entity is a thing in the real world with an independent existence, or it can also be a conceptual existence. We can also call it as an entities. Example for an entity is a person, car, house or employee, or it may be an object with a conceptual existence. For example, a company, a job or a university courses. These are all we can call it as an example for the entity. Each entity will have an attribute. The attribute can be defined. The particular property of an entity we can call it as attributes. For example, we can also say a property of an entity we can call it as an attribute. Example, if you consider an employee, so the employee will be having a employee ID, employee name, employee date of birth, employee address, age, salary. These are all we can call it as the description of the entity, that is employee. this entity described by using these are all things like employee name, age, address, salary and job. These are all we can call it as attribute. This is about your entity, and as well as attribute means what. Now we will see the different set of attributes which are using in entity relationship model. There are several types of attributes occurs in an entity relationship model. The first type of attributes are simple versus composite attributes. Second set of attributes are single valued versus multi-valued attribute. And the third set of attributes are stored versus derived attribute. And one more is there, null attribute. We can also call it as null attribute. So these are the different or several set of attributes which we are using for entity relationship model. Before going to learn the different set of attributes, we should know the entity relationship diagram notations. So to draw the entity relationship diagram, we are using the following notations. So these are the symbols and these are the meaning of those symbols. So first notation is rectangle box. So which will represents in a ER schema diagram, that is entity type. Double rectangle box indicates for the weak entity types. To represent an weak entity type, we are using double rectangle box. So to strong entity type, we are using a single rectangle box. If it is a diamond shape, then so we are used for the relationship type. And if it is a double diamond shape, then it is identifying a relationship type. And oval with a line, so we can call it as a attribute. To represent an attribute, we are using this symbol. So if it is a key attribute, inside the oval there will be an underline, so that representation we can call it as a key attribute. The multi-valued attribute will be represented by using a double oval with a line, so that is representation or notation used for the multi-valued attribute. And if it is a composite attributes, then we are using a single attribute is subdivided into small sub attributes, that is represented by a separate ovals which are connected to an attribute. So this is a composite attribute. And derived attribute, which is represented by using a dotted oval. So this dotted oval along with the single line represents a derived attribute. Now, so these three symbols are there. These three symbols will give a clear picture about the participation constraints and as well as cardinality ratio constraint. Both together we are calling it as structural constraints on participation of entities or both entities in a relation R. So this is how we are representing a strong entity. Let us consider example E1 they have given, E2 they have given. So now these two entities are participating in this relationship type R. So this will be represented by using a relationship type symbol. This is a diamond. This diamond, so how this entity is participating in this relationship type, that will be explaining by using this relationship type. And as well as this single line and double line represents the total participation and as well as partial participation representation. If there is a single line, so from the entity type to relationship type, then so we are calling it as partial participation. If there is a double line between the entity type and as well as relationship type, then we are calling it as total participation. So then second symbol is there, or second notation is there. There is an entities are there E1 and E2, they are participating in a relationship type R. Then the cardinality ratio will be represented by using either 1:1, 1:n or m:n manner. Based on the maximum participation constraints, we will going to represent under the cardinality ratio. Then last one is there, that is structural constraint. So if you are not representing a cardinality ratio by using single line or double line representation, then one more representation or notation you can use, that is we can call it as min-max representation. This min-max representation we are also calling it as structural constraint, where so both total participation and cardinality ratio both together we can call it as structural constraints, where it is represented by using a min-max, where so the entity type which is participating in a relationship type, that is represented by using a single line, so along with the min-max labels. This is a different set of notations we are using for your entity relationship diagram. Now we will discuss about the different types of the attributes which we have learnt, that is simple versus composite, single valued versus multi-valued, and stored versus derived attribute. There are three set of attributes are there. First one, this is the second one, and this one is the third one. Now we will uh, discuss about these three set of attributes, different set of attributes with an example. First one is simple versus composite attribute. The simple attribute is nothing but the attribute that are not divisible is called a simple attribute. The attribute which are subdivisible, that are all we are calling it as a composite attribute. Example, class, roll number, these two are simple attribute where which cannot be divisible or further so divided into sub attributes. But in case of address, address can be divisible. Therefore, address we are calling it as composite attribute. Class and roll number will be a simple attribute. Now these two attributes will be represented. So for an entity type, here you can see a student is an entity type. So for this student, these three attributes are related. You can see here roll number. So how to represent an attribute? So attribute will be represented by using a oval symbol along with the line, okay, and then if it is underlined, then we will call it as a key attribute. Okay, this is the key attribute. So this is connected to an entity type, that is student, and class, it is also an attribute. This is a simple attribute, so which is also connected to a student. But age is also a simple attribute which is also connected to an entity. These three are the examples for the simple attribute. Now you can see the same student entity relationship diagram. Here roll number is the primary key. So here we have a address attribute, but address attribute is the composite attribute. Why? Because we have a street name, city name, state name. So means this attribute is further divided into so sub attributes. Therefore this kind of attribute we are calling it as composite attribute. Okay, but name is not a composite attribute, or else you can also consider name is also a composite attribute, where once again the name is divided into subcategories: first name, last name, and as well as middle name. This is how we are representing simple versus composite attribute definition, example along with entity relationship diagram. The second set of attribute is single valued versus multi-valued attribute. The most attributes have a single value for an particular entity, that we are calling it, that kind of attribute we are calling it as single valued attribute. For example, age is nothing but it is only a single value. We doesn't have a two or more number of ages for a particular person. So there should have a only one age, either 6, 7, 8, 10, 20 like that. So then that is what we are calling it as a so example for the single valued attribute. But multi-valued attributes are the attributes that attribute will have a lower bound and as well as upper bound for the constraints, the number of values. That is, lower bound and upper bound means there will be a two or more number of values will be existed for that attribute. For example, you can see here, so mobile number, So and as well as email ID. The mobile number and email ID we can call it as multi-valued attributes, but class and genders are there. These two are single valued attribute. Gender is either male or female. The class can be a first year, second year, third year, like that. So these two are the single valued attribute and these two are the multi-valued attribute. Now we will see how we are representing in the entity relationship diagram. So now this single valued attribute we can represent like this. These are all we can call it as single valued attribute. So these are all attributes are represented by using a oval symbol with a line. You can see here the strong entities are representing by using a rectangle boxes. Okay. So this is an example or entity relationship example for an single valued attribute. Then multi-valued attribute will be represented by using a oval symbols, that is double oval symbols. You can see here roll number, age is there. These two are the single valued attribute of a student entity type. Mobile number and email IDs are there. These two are the multi-valued attribute. Why? Because each person may have more than one mobile number. Either two numbers are there, or three numbers are there, four numbers are there. Then these are all we are calling it as a multi-valued attribute. And then similarly a person may have a two or more number of email IDs. Okay, then these two kinds of attribute we can call it as multi-valued attributes. Then third type of attributes are stored versus derived attribute. In some cases, two or more attribute values are related to each other. For example, you can see the age and the birth date are related to each other. So this kind of attribute or this kind of values comes under the stored versus derived attribute. For example, now you can see here the age attribute is hence called it as a derived attribute. So and birth date is there. The birth date we can call it as a stored attribute. Why? Because derived attribute is said to be derivable from the birth date attribute, which is called a stored attribute. Okay, now you can see here without knowing the birth date we can't calculate the age value. Therefore, age is the derived attribute and birth date is the stored attribute. If birth date is stored, then we can identify the age of a person. If we don't know the birth date, then we can't identify the age. By using age in the reverse process, we can't identify the birth date. Okay, so therefore, here the birth date will be the stored attribute and age will be the derived attribute. Now we will see how we are representing this stored attribute and as well as derived attribute in a entity relationship diagram. This below is the diagram of an student entity type. So roll number, gender, date of birth is there. These are all we are calling it as a normal attributes. Gender and as well as roll numbers are the single valued attribute, but date of birth is there. This date of birth is the stored attribute and age will be the derived attribute. That derived attribute will be represented by using a dotted oval along with the line connected to an entity type. This is we are calling it as a derived attribute. Okay, and this one we are calling it as a stored attribute. These are the how we are representing derived attribute and stored attribute in an entity relationship diagram. Now one more attribute type is there, that is a null valued attribute. So the null valued attributes are nothing but a particular entity may not have an applicable value for an attribute. In that case, it will be represented by using a null. For example, let us consider in a student table, a student will have a USN, name, mobile number, then PAN card number, driving license number. some of the students will have a PAN card number, so some of the students will have a driving license number, but some of the students in that group, they may not have a license, driving license, or some of the students, they may not have a PAN card number. In that case, that will be represented by using a null value. Example, here they have given apartment. Apartment, some of the houses, they don't have a apartment number. Some of the houses, they have a apartment number. So for this attribute, particular attribute, which will be applicable for some rows, and some of the rows, this particular domain value is not applicable. In that case, we are representing it by using a null value. And last attribute type is complex attribute. Notice that composite is and a multi-valued attribute can be nested arbitrarily. Here what we are doing means we are nesting the two attributes, that is, one is composite attribute and as well as multi-valued attribute. So once it is nested, then we are calling it as a complex attribute. How we are nesting? So we can arbitrary nesting by grouping the components of the composite attribute between the parentheses and separating the components with the commas, and by displaying multi-valued attributes between the braces, that is flower braces. So such attributes we are calling it as complex attribute. That complex attribute we are also calling it as a combination of composite and as well as multi-valued attribute. You can see in this example there is a flower braces that is displaying a multi-valued attribute, but here address phone number is there. Inside the address phone number there is a once again a composite attribute is there, like phone number. Phone number will includes the area code, phone number, and similarly address will be having a, this is the multi-valued attribute, street address, number, so apartment number, city, state, zip code. These are all we can call it as, it is the combination of composite attribute and as well as multi-valued attribute. If it is nested one within another, then that attribute we are calling it as complex attribute. So you can see here, this is an entity relationship diagram for representing the complex attribute. So here this is an employee entity type. This employee entity type is having an attribute, that is address. The address is so having a street address. Once again, this street address is split into sub attributes, that is door number and as well as so street name. So then this kind of representation we are calling it as complex attribute. So here city and pin code will be there in the normal attribute, but especially street address is there, that is divided into sub attributes or nested attribute. Therefore this kind of representation will be done in the ER diagram.